Okay, so the recording is started. Let's get started with today's topic. Important discussions. We are going to discuss about one very popular and common practice in microservices, which is using Eureka Server, okay, and Eureka Client. Okay, so what exactly is that? What is the need of this? How to technically implement? All that is going to be part of today's session. Okay. So for understanding it, we need to go back to our drawing board. Everybody, please put attention. We are getting started with the topic. Okay, let's start. Important discussions. Let's go. Yesterday topic also circuit breaker. Highlight it in your resume. Even today's topic as well. So we are dealing with microservices. And where does this come in picture? Okay, is when one microservice tries to communicate with another microservice. This is where this concept is going to be applicable. So just imagine we have processing service and we have Stripe provider service. Currently in our code, how have we done it, guys? Okay, local processing service, when it is trying to connect to Stripe provider service, we have provided it in this manner, like it is running in the local host itself. Even when we did the AWS dev environment, we realized that there in the same EC2 machine, processing service was running and Stripe provider was running. So keeping it local host means wherever you are running this service in the same machine on 8083, this Stripe provider is running. Okay, but production scenarios are going to be different. So the configuration that we will do here is going to be different. Okay, so first of all, how it is going to happen in your environments. Currently, we have done the coding in this manner. Localhost, try to connect via localhost. Okay, however, in microservice communication, okay, in microservice communication, there are two commonly used style. Different projects might use different ones. Two commonly used styles. One approach is via load balancer. Okay, via, in fact, let's say AWS or cloud load balancer. And the second approach is via a service registry. Service registry, which is nothing but using Eureka Server and Eureka Client. So these are two popular ways by which two microservices can connect to each other. First approach, we discussed it earlier, but let's quickly recap. Microservices are auto-scalable. That's the core nature. It can scale. What is scaling? When more traffic comes, more number of instances will run. When more traffic is coming, so let's say currently only one instance is running. If more traffic comes, we will have another machine. Then third, we will have another machine. Okay. So during our AWS, we spoke that our approach will be, this will be a separate EC2 machine. This is going to be separate EC2 machine. And like this will be a separate EC2 machine. So we will create a separate machine and on that machine run these individual microservices. The machine size could be depending upon your need, 1 core 2 GB or 2 core 4 GB. Generally, that is enough to run one service very happily. And it can be horizontally scaled, means more and more instances, more and more services. Okay. So that is what is the first thing we need to understand. Microservices are scalable. Okay. For each MS, we will run in a separate EC2 machine. During interview time, speak about this approach. There are n number of ways. For cost saving, you can put everything together and all, but just say this is a clean approach and we guys are deciding to go it like this. Okay. So, and easy to scale also. This approach, you can configure it very nicely in AWS and it can take effect very smoothly. So, and it is okay. It is efficient approach. So we are going to do it like this. For each microservice, we will run it in a separate EC2 machine. So this is going to be the scenario. And before that, there is going to be a load balancer. So again, in AWS, we can set up a load balancer, okay? And people generally call it as ALB, application load balancer, okay? Application load balancer. So whenever this source service wants to connect to this guy is going to talk to this load balancer. This is approach number one that we are discussing. And the work of the load balancer is to balance the load. So depending upon whichever server is lightly available, this guy is going to talk to them. Okay, so one request might go here, another can go here. It depends, right? That's load balancing logic. So that is the approach number one, how microservices communicate with each other. So what are you supposed to learn and draw conclusion from this is, when we are deploying this in our production system, or let's say some UAT environment or QA environment, where they have done this kind of a setup. So in that case, in this property file, you will not mention localhost 8083, rather you will specify this load balancer related details. It could be load balancer IP or load balancer DNS. So DNS is like domain or IP. So what is going to happen? Step number one, in your property file, the way database, right? When we try to connect to database, we got a name of that database, right? For example, if you go to dev property file, we got this name, right? Similarly, when you're trying to connect to load balancer also, when you set up load balancer, it will get some identification, and this kind of name we will take and we will be setting it up here. And then step number one will be that. Second step will be some guy, maybe DevOps or your senior. Sometimes if you're working in small teams, maybe you also will be expected to do some configuration in the load balancer side, so that behind the screen you can route the request to the destination EC2 service. So that kind of configuration, many times DevOps or your seniors will take care. Juniors might not be really required, because this is one time setup. But yeah, this is what approach will be. So what is the approach number one? Approach number one of communication, we set up microservice as auto scalable, okay, for each MS, a new EC2 machine. Okay, next, put an application load balancer before the, okay, some people might say cluster of EC2. Okay, some people might say cluster of EC2. And then in property file, put, okay, instead of directly calling destination microservice, you call to load balancer endpoint. Next, in load balancer, provide configuration to route the request. These are the terms, okay, to route the request to destination microservice based on load. Okay, so this much is the approach number one, how it is going to actually run it in the production environment. Okay, so guys, are we clear with this approach? So it is easy to set up, easy to use. Some AWS configuration knowledge will be required, but it can be set up by one person. Are we clear with this, guys? Give a quick thumbs up. Hello, are you there? Chalo, chalo, guys. Yeah, it's 2nd of October. You will be like, come on, you have got us on 2nd October also. Bapu. Okay, chalo, guys, let's start. Okay. Now, the next thing comes somewhere like this. Approach number two. Approach two of communication. So guys, what is this approach number 2? We will have something called as a service registry. The name is very logical. Registry of services means it is going to track all the services of the system. Guys, everybody focus. Approach number 2. We will be again having these things. Let me just copy this. Let us just copy this and put it here. Here, not this way. So I will remove this. Okay. Multiple instances will be there in the approach number 2 also, because scalable is the basic need. So we need to always be like this. Now, the second thing will be, we will have a separate component in the system called as a service registry. Okay. Let's put this into maybe this box kind of shape, just some representation. This we call it as a service registry. Okay. So what is going to happen? Whenever any microservice, let's say even this or this, whenever these microservices come up, their work is they need to be registered with this service registry. So this is going to happen. Whenever any microservice is coming up, they will be registered here. This guy also, this guy also, this guy also. So you can imagine something like a map, kind of map, you are putting all the values. That is the step number 1. Okay. Step number 2, whenever one service wants to call the another service, so what they will do is they will connect to this service registry and they will get the details about the destination service, and then they will actually call whichever destination service, let's say this one. Okay. So this operation of getting the details from destination, we generally call it as what, guys? We generally call it as lookup operation. Okay. So this process is a lookup operation, and then you call the destination. Invoke destination. So that is how the communication is going to be, guys. So it's a different style of communication. In between this and this, here we are not using AWS kind of any load balancer. Okay, we have a different approach. Every service registers here, and via this you can make an API call. For many of the projects, even this kind of style is implemented for service to service communication. Okay. Now, the projects where there are many microservices, let's say 40, 50 microservices and multiple instances running, for that they recommend to go ahead with this kind of an approach. Okay. Because these calls and everything is very nicely optimized. And if more number of services are there, configuring all those things here will become very hard to maintain. Configure everything here will become very hard to maintain if there are 50 services or something. So now what is required in such cases? These things work more efficiently. Okay. Even like Spring Boot team has optimized this in a manner it is going to be faster communication and everything. So for big systems with lot of microservice, people prefer to go ahead with this approach. Now for a decent system, small scale, mid scale, with less configurations, you can get the work done. So this is easy to set up. From technical perspective, you don't have to do anything. You just configure in AWS, point to the endpoint, no other code change. But when you're doing this, you need to work with some more annotations, some more configurations, so that we have to understand. But please note, there are two primary ways by which service to service communication is going to happen. One is this approach via load balancer routed to the destination. Second approach is something like this, guys. Okay. And the second approach goes, you register here, step 1. Whenever a service comes up, you register to this service registry. And then when you want to call it, you basically do a lookup. And then third is where you actually call. Okay, simple 3-step process. Let's write down some pointers about it. So here also, Microservice will be set up in a auto scalable manner. That will be as it is. Here also, for each microservice, let's say new instance you are using. So we will continue with that setup in that manner, no change at all. Okay, next, you will not have a direct application load balancer setup. Your approach will be, when any service comes up, they register to central service registry. Okay, service registry, a registry where all the services will be registered. That's it. Okay. Second, when one service wants to call another service, they look up from the service registry and then will get the right instance and then call the destination service. This is going to be our approach number 2. Okay. Now, you need to understand a few more things here from the production related perspective, that this is auto scalable. This is also auto scalable. Please note that this service registry also needs to be set up in the manner that it does not become a single point of failure. Okay. So then how do people do it? They will set up this service registry also as a cluster. Nothing but more than one machines will be there of this nature. So let's say more than one, and they will be set up as whatever data is available in this, it will be available here also. It's going to be in sync. Kind of, they will be set up as peers so that they can communicate. So if in this service registry, they have registered all these 4 instances, it will be synced here also. So both of them know it. Okay. So like that kind of configuration will be done. And for many of the systems, before you call the service registry, all of these guys, before they call the service registry, what they do, they put a load balancer in this case also, because now there are multiple service registries. So you can still put the architecture design in this manner. So first of all, let me just keep it as it is. We will draw some improvement on top of this. So how exactly this should go in a production based system? So they will just move it something like this, out, up, okay, up, and then put one more instance and then run it as a peer, sharing information with one another. Next, before this, you put a load balancer, and whenever you want to reach out to this service registry, you will go via this place itself. So by that way, even this doesn't become a single point of failure. All your requests and responses are routed from this load balancer to this service registry. For many projects, this kind of setup is available. So in order not to have a single point of failure, okay, so like this kind of thing will be there. Between services, you're not using this kind of load balancer, but even service registry has to run as an like multiple instances, so it doesn't become a single point of failure. So this is how it can be achieved. You can put, let's say, an application ALB, and this is going to become service registry. So please be aware, it depends. You might choose this kind of a setup for your project. So it is also possible. So let's write down this additional thing. Even service registry should not be set up, okay, as a single point of failure. Okay, so general practice is to run it in cluster. So all data will be in sync across all service registry instances. Okay, and you can access service registry via ALB, application load balancer. So this kind of a complete solution people can implement. Okay. Now, Guys, did we get this? Team, are we good? Did we get this part? Okay. Everybody, please be focused. Are we getting it? Guys, listen, chalo. Okay, so thanks for confirmation. Let's continue forward. Very good. So now how to implement it technically? Let's go to the implementation part of the approach number 2. Okay, so there are multiple ways to implement this service registry based approach. Multiple ways, multiple libraries are available. Okay, one of the very popular ways given by Netflix. So people use it as a OTT platform for entertainment purpose, but behind the screen, it's a big technology company developing softwares and even contributing to Spring. Netflix is one of a very big user of Spring. So whenever Spring conferences happen, people, the developers, technical experts from Netflix come to those Spring conferences and they share how they are implementing Spring to really run their highly scalable system. So that kind of communication. So Netflix has also contributed to some kind of code and jars to the Spring community as well. So one of the popular commonly used solution for service registry is contributed by Netflix here, and the name is as Eureka Server and then using a Eureka client. Okay, so Netflix has offered these kind of solutions in order to achieve this approach number 2, a service registry based communication. Okay, service registry based communication. So what is going to happen? This service registry can be implemented using this concept as Eureka server. So we call this as Eureka server. Okay, next. All these other things, we call it as Eureka client. Okay, all these other things we call Eureka client, which is going to be this plus this and these other two also. These are all Eureka clients. Okay, so accordingly they have provided some code to us, so we need to add some jar dependencies and use it in project. Okay, now in order to build this, what we are going to do? Okay, so firstly we will, from coding perspective, now what is going to be our actions? So we will create a separate Spring Boot project and call it as a Eureka server. So our step will be, currently we have payment processing service, Stripe provider service. Now our approach will be, we need to create a third service called as, let's say, Eureka Service Registry. This is going to be a separate Spring Boot application. This application, we will set it up like a Eureka server. Okay, so first we need to do this thing. So how to do it, what are the configurations, everything we will understand when we are technically doing it. Okay, fine. Now the next thing, these two services should be set up as Eureka client. So some annotations, some configurations, form dependencies, that will be there. So that will be our second approach. The first approach is to do like this. Second approach is make these two Eureka client so that they can register themselves to service registry. If they don't register, they cannot look up and they cannot call to each other. So that will be our second stage. Each microservice should register itself to service registry. First, we will create a service registry. Second, each microservice should register to service registry. And third approach will be actually doing a lookup when processing service is trying to call Stripe provider. So this much, 3 changes we are supposed to do. Okay. So guys, one by one, let's get started. One by one, let's get started. So already I have created a getting started project the way we have earlier shared, right? Payment processing getting started, Stripe provider getting started. So like that, I have already created a getting started project. So I will upload this into our Google Drive also. You take it, set it up, and then continue. So we have getting started project for Eureka Service Registry. Okay, so it is going to be something like this. Let me go. It is going to be available right now. It is in my local. I will upload it in Google Drive. Something like this, Eureka Service Registry. This zip file, I will upload it in Google Drive. For now, I am extracting it here itself. So right click, extract all. So let's put it here. Okay. Eureka Service Registry. It is having the same folder name, so I'm just correcting the folder structure here properly. And then we can delete this empty folder. Okay, so first step will be you check it out. You set it up into your local machine. So all these are basic things. Right click, import existing Maven project. You take this, you put this, next, next, finish. Again, it's just going to be like the basic getting started project, having just one main method related class. There is one test empty controller, and then there is profiling concept enabled and basic pom.xml, similar to other places. Once you have it, make sure you are putting it in Bitbucket and all those branching related stuff as well. Once we do all that, then we can do right click, run as. Let's do a package, clean package. So step number one will be set up the getting started project. Okay, fine. So we will test it into local. So this build is successful. Service registry is locally building. A few things you need to understand about service registry. Generally, it is recommended, or default port is going to be 8761. So generally people use this as the default port for service registry. Please be aware of that. Okay, 8761. So we can just put it here in a diagram. 8761 is the port of this service registry. Okay, fine. So step number one is first just set up this one. Now we need to make it a Eureka server. Some multiple factors we will learn it in the process. I have already arranged all the configurations as part of one document. So all the changes which were required, I've just put in here what POM dependencies come into this picture. You can find all the changes here. Okay. So basically, you just need to add a POM dependency saying Netflix Eureka server. Then again, the way like we mentioned yesterday, Spring Cloud versioning is taken care. So this is also available as part of Spring Cloud project itself. And for versioning, we have the same bill of material configuration. So we need to add that separate dependency also. So first, if we do this, we get the required jar files to make this as a Eureka server. Okay. Next, We need to use one annotation. Wherever your main method class is there, just call there enable Eureka server. So it will behave like a Eureka server, which means it will become like a service registry where others can register, when others can look up from. Okay, so it will start behaving like a service registry project. So that is what is going to be our next thing. Third, some configuration changes are there, which is required for service registry to function properly. So you can do a lot of customizations to this. And in Spring documentation also, they have explained all the configurations in proper manner. You can go to ChatGPT. It can help you with right a set of configurations to use. That's it. You basically just do this kind of a setup and your server application will be ready. So let's start applying it one by one. Okay. First of all, form.xml change. So guys, now we are doing the second step. Step number one is set up the getting started project. Step number two, okay, make this as Netflix Eureka server. Okay, for that, this document I will be sharing with you. You can go to ChatGPT, it can give you everything. I have just arranged it at one place, already did that kind of work. Okay, but you go to ChatGPT, it will fill it. By the end of the session, we can just spend some time in reading through what ChatGPT is giving. Okay, so fine, this is what it is. So we go to form.xml of service registry. All the basic dependencies are there. We will be adding this. Okay. It needs the version. So we need to add this second configuration, which will take care of all this cloud kind of projects related main configuration. Okay. The version error issue is gone. Now you save it. Okay. That is step number one. Whenever we make changes here, immediately right click, run as, build, clean package. Okay. So looks like it's expecting us to provide some configurations. Yeah. So basically it is looking for other Eureka related configurations. So the way we know auto configurations happen. So let's enable the rest of the changes also. So build is failing because of that. We will make this as a enable Eureka server. So go to the beginning place, enable Eureka server. So this will make it a Eureka server, and server.port already is finalized. So we don't have to write it. Local, this one, server.port is 8761, and application name is Eureka Service Registry. So these two things are already there, so we don't have to add it. But remaining configurations we need to apply. What are these configurations? We will discuss it shortly. But let's go to, we are running it in local. So we are making changes here. Okay, what these configurations are, we will understand. But first, let's try to start the system and then we will discuss these things one by one. So three things we have done. Everything is saved. Right click, run as, build, clean package. Try to read the names of the fields. Eureka client, register with Eureka, false. Okay, fetch registry, false. Okay, this time build is successful. means whatever configurations it was looking for, it found everything. Dekho, one important thing, these two things we are turning it false. Okay, why? Eureka client register with Eureka. Okay, nothing but when you add this, even the server dependency, it tries to register that instance to the same Eureka server. So kind of self loop it tries to do. So we don't want that to happen. So just observe, if you are looking from client perspective, you need to do two actions. One is register, second is lookup. Lookup is like get, register is like register. So these two fields basically define that. Okay, do you want to register with Eureka? Because this is also a Spring Boot application itself, and it is coming up. So we have to turn this off. Okay, do you want to self-register? So no, we don't want to self-register. So we are just turning, do you want to register with Eureka? False. And do you want to fetch? Nothing but for lookup actions you will be using. So we put that also as false. So please understand, these two are the major ones which we have to always apply. These remaining things are depending upon the need of your project. Sensible defaults will also always be available. But for experimenting purpose, we have used some of these values. Okay. What is the purpose of all this? We will understand it in some time. But these two things are important to understand. What is it? Eureka server will try to register itself to the service registry, okay, or for fetching up actions. We don't want that to happen. So we are turning it off. We simply turn these two flags off. So this is important. Okay. So please make sure you're doing this. This you have to turn it in false, and remaining configurations you are already aware. So pom.xml configurations will be there, and some annotation, enable Eureka server changes available. And the third one is property file changes. Property file changes, which includes these two things. Okay, fine. Now, once it is done, let's bring this server up and running. Okay, start Eureka server. So how do we do that? Right click, run as. Let's start a Spring Boot application. Already package happened. Now we are starting it. Okay, let's see how it is going. Okay, so observe, updating port 28761. Okay, fine. Updating port 28761. Just observe what is happening. There is a running and evict task. Evict means to remove. So just observe, it is continuously running after some time. How much time difference is there? 32 to 37, 5 seconds. 37, 38, 39, 40, 41, 42. So every 5 seconds, some kind of a eviction is running. Evict means to remove. So nothing but in our property file, we have configured these additional behaviors. Okay. For example, we have configured eviction time like this. So again, for testing purpose, it is there. For production, people will accordingly set up values. You can go and explore on ChatGPT for some relevant values and discuss it in your project. How much this eviction time should be? Eviction is what? Okay, let's say now a lot of additional logic is going to come in this place. Just imagine if these 3 instances are connected to this guy. So they are all registered. Now, question, if this service goes down, so there has to be some way that from this also it should be removed. Otherwise, when somebody is looking up, it might give that stopped service also, and you might try to call, an API failure will happen. So because of this, service registry should always reflect the latest services which are up and running. So these kind of eviction related processes will be there. So we are saying every 5 seconds, keep checking, okay, whether the services are up or not, and then remove all the unused ones. So like this kind of additional configurations could be there. Okay. So it runs every 5 seconds, and then it checks that since past 10 seconds we have not received. So nothing but, please understand, a lot of configurations which define that service registry should maintain latest active instances. If some instance goes down, service registry checks on that. And once it realizes that machine is no longer available, service registry cleans up that information also. So this additional work needs to happen. Don't worry, we don't do it manually. Under the hood, it will happen. You can set up some configurations to make it possible. Okay, okay, fine. So now let's continue. So what have we done? We have started, or let's write down one liner about it. Start Eureka server, one liner. Service registry should always hold currently active instances. If any instance is not running, that should be removed from service registry. So internally they have a way called as heartbeat. Heartbeat, it's like the way our heart beats. So these guys will continuously keep giving some signals to Eureka server. I am alive, I am alive, I am alive, I am alive. Under the hood, it will keep happening. Okay. Now, as soon as this heartbeat stops coming to Eureka server, so then Eureka server realizes, oh, there is something wrong. That guy is not telling me that I am alive, I am alive. Maybe it went down. And then that guy is going to do some checks and accordingly remove that configuration so that when somebody tries to look up, they don't get the stopped services. So that kind of heartbeat based communication is going to be available between these clients and the server. Okay, fine. Just be aware, this is a very common network approach which people follow for knowing whether the system is up and running. Heartbeat kind of concept. Once this machine keeps telling the other machine, I am up, I am up, I am up, I am up. As soon as it is down, that message stops coming and destination realizes, oh, there is something wrong. It does a quick check and accordingly does the handling process, whatever it wants to do. Okay, fine. So chalo, we have understood this concept. We are already running it. We know that it is running on some specific port 8731, 8761. Okay. Now, what these Eureka server people have done it, they have created a nice web application. Okay. Netflix Eureka server people, they created a nice web application which we can call it as Eureka server console, where you can do monitoring, if how many services are registered right now and other things. You can simply access it. So wherever you are running it, just based upon the port number, you can access it. Just copy this URL and access it into browser. Just observe Spring Eureka. It's a nice web application which comes in picture, and where it's a monitoring dashboard which will tell about what instances are running. Okay, that kind of information you can find about all the clients, and next, what is the current time, this is up since how much time. So some kind of additional information you can find it here. When you are running it as a cluster replications, you can find that information also in the section. So some information is coming here, and the current state of this is up and running, on which IP it is running. So this is my machine IP. So it is just identifying certain information. Okay. It is just giving some warning messages. What is that warning message? Okay. Renewals are less than the threshold. Okay. Nothing but right now we don't have any client machines, and new instances are not running, auto scaling, all that is not happening. So it is saying, hey, renewals are lesser than the threshold because we have not done anything. Once the system becomes full-fledged, this error message is going to go away. Okay. Once the full system comes in and we are running it in cloud and AWS with all configurations, and when one machine is down, renewals are automatically happening, scaling is automatically happening. then this message is going to go away. Currently, we're testing it in our local, so this is a temporary message that comes to us. Okay. Second thing, try to understand. Self-preservation mode is turned off. What is this self-preservation mode? Okay, you go back here. We have said self-preservation is false. When you are in non-production environment, there you can set it up like this. But in production, the value should be true. Okay. What is the self-preservation mode? The error message is clearly explaining. Self-preservation is turned off. This may not protect instance expiry in case of network or other problems. Okay. So what exactly is this self-preservation mode? It is basically, some time ago we said heartbeat communication is going to happen. Every time these services regularly, repeatedly, it will keep informing to this guy. And we said, as soon as they stop doing it, they will do some checks and they will then delete it. Okay. When the self-preservation is on, let's say it is true, we need to understand sometimes network problem might come. So what can happen? Service is up and running and it is trying to do a heartbeat sent on the network. Some network packet might be dropped, so your message did not reach there. Okay. So service registry might assume, okay, hey, I did not receive the message, and then it deletes it. So we don't want that to happen, because in a production system, sometimes network might cause some issue. So we don't want service registry to immediately act. As soon as it does not receive even the first message, it should remove it. No, we don't want to do that. So in production, you want to give some more buffer, that if you are not receiving some heartbeats, immediately don't remove it. Still keep it for some time. That is what is self-preservation. Self-preservation. So even without heartbeat coming to you, you still wait for some time. Don't act immediately. Compared to in the non-production environment, sometimes you might just get a network problem and still you might be just removing that configuration. So please don't do that. So this value is supposed to be there in false in the dev environment. However, in the production, it is supposed to be in a true state. So it will wait, it will give some buffer time, it will not remove the configuration. So what are we understanding here? So there are multiple properties which take an effect on how the Eureka communication is going to happen, server, client, and behavior. Okay, fine. Let's continue further. So we spoke about this. Start the Eureka server, and then we understood certain factors regarding that. And then Eureka server console is there, where you can monitor information about Eureka, and you can simply access it wherever your application is running on that port. It is by default accessible. Okay, first part is completed. What is that first part? We need to set up a Eureka server. That work is completed. Now, second, next step, third step done. Fourth, all other microservices should register themselves as Eureka client, okay, to this service registry. Guys, the first approach is clear, everyone? Team, could you please give a quick confirmation? The first approach is clear? Nice. अभी second देखते हैं. Every destination service, let's say payment processing service, type provider service, they need to register as a client. So then only they can do lookup activity. So first they register, and then they want to do the lookup, they connect, and then they can call the other. If Stripe provider is not registered, processing service cannot call it, because when processing tries to do lookup, it does not find Stripe provider and will not be able to do. So it is a very logical approach. Let's observe that. Okay, let's observe that. First step, processing service also register, this guy also register. Next, whenever they want to call each other, they look up and then they call. So if registration does not happen, they cannot call each other. That's what is the funda here. Okay, so our next aim is processing service and Stripe provider. Okay, both of them should be enabled as Eureka client, so they can register to service registry. How to do that? Again, some POM configurations will be there, some annotations will be there, some property files will be there, property configurations will be available. Okay, one by one, let's apply that. So first of all, we go to processing service. Okay, let's just observe Netflix Eureka client. For some monitoring purpose, you can add actuator also. And this is also coming from Spring Cloud. So BOM dependencies available for this one. Okay, fine. This is change number one. This is change number one. After that, this one is optional. With latest version of Spring, they have made it optional. But still, on the main class, we can put enable discovery client. Okay, we can put this kind of an annotation, enable discovery client, which will make this as a Eureka client. Okay, next, we need to just provide this configuration. What are these configurations? We will understand it. Okay, we will understand it shortly. That's it. Only 3 changes we have to do. Let's start doing it one by one, and then we will keep understanding it as we go forward. So first of all, yes, we need to have these 2 dependencies in processing service. So go to the pom.xml of processing service. Notice in processing service, yesterday when we coded, we already added circuit breaker there, right? Already circuit breaker is added, actuator is added. Because of circuit breaker, Spring Cloud configuration we added, and we already added this BOM configurations also. So we have to be careful when we are applying these changes. Since actuator is already there, so we will not take actuator. Only this configuration is required. So take this and then put it here. Okay. Next, the second configuration also, we don't have to put it because yesterday we have already added that. So the same configuration works, right? Spring Cloud, all the Spring Cloud related, whatever tools they have given for microservices, they can all be accessible. So ease of version maintenance is coming. So you don't have to add second thing because we have already done it yesterday itself for circuit breaker. If you don't have that, then you have to include all the 3 configurations. So please be aware of that. Okay, fine. So first step, we put this. Let's do a quick save. Okay. Let's do the remaining configuration also. What is that? On our main application, we will be putting enable discovery client. So we go here, processing service. Here we go to the main application and put here enable discovery client, Control Shift O. Because of the POM dependency, the import is happening properly. You do a save. Step number 2 completed. Enable discovery client, POM, enable discovery client. Step number 3, we need to put this configuration. These 2 things are already there, server port and application name. So no need to change anything here, right? So application dot properties of processing service, server port is already there, Spring application name already there. So we don't have to reapply this. Okay. Next comes the Eureka configuration. Let's try to put this first, then we will try to understand what these values indicate. Okay, let's go here. Not here, in the local we can put it. So you go to the local, and here after circuit breaker, we will mention this kind of configuration. Let's do a save. Okay, let's clean it and start the project. Let's see what happens. So processing service, right click, run as, build, clean package, save everything. Yes, that's what. Always save everything. Don't forget it. Otherwise, sometimes without your save, you are running it and you will be like, what is going on? Why my changes are not reflecting? Silly mistakes can take a lot of your time. So stick with the basics. Always errors are not there. Everything is saved before you do that. Okay. So simple things can save a lot of your time and effort. Okay. We are doing a package right now. Hmm. Hmm. Okay. This is good. Let's start the application. Here we go. Right click, run as Spring Boot application. Okay. Let's go. Hmm. Guys, observe here something more happened additionally. Discovery client, com.netflix. Right? Netflix company has developed it. So com.netflix. We are developing it. So com.hulkhighertech. So the company which develops, their domain in reverse is the starting of the package. That's the group ID. So com.netflix. Okay, fine. They have taken it up. Next. And some loggers are available. That's all fine. But discovery client, we have enabled discovery client. What this guy is basically doing, let's try to observe. Okay, discovery client is trying to register the application, our current Spring Boot application, registering application payment processing service with Eureka with status up. Nothing but this is the registration action. So automatically, we don't have to do additional, just add this form and all, Spring Beans will be activated, auto configuration is going to work, and it is trying to register the processing service to Eureka server, okay, with status up, means currently I am up and running. Okay, this is what is the important thing. On service startup, we are getting below log message. So that means it's registering. Okay, what does it mean? You can go here to the console and refresh this page once. Observe here. In the application section, earlier empty row was there. Now there is one service registered here. Observe, payment processing service. Okay, whatever name we have used for Spring application name, application.properties. Here we have used this name, right? Payment processing service. Internally, it has just turned it into capital, and that kind of name we are able to see here. Your application name is going here, and it is identifying, okay, one instance is up and running. Okay. Now, how this is called as instance ID. So one instance is up and running. So it is going to give a clarity. Let's say all the three instances of Stripe provider. Let's say you are starting a Stripe provider. All the three is going to have the same name called as Stripe provider service, right? Even though they run it on three different machines, they all will have the same name, Stripe provider service. But they will be three different instances. So how can you have this information? Okay, three instances are running. Okay, in service registry, that information will be available here. Here you can find that three instances of this service is running. Okay, we will take some example today to even test this case where multiple destination services are there, but one by one. But I'm just trying to walk through this configuration with you. It simply means this instance is up, and this is an instance of this microservice. If there are 20 instances, because of auto scaling, you will see here 20 configurations here, 20 instance IDs will be there. Okay, fine. That is the next thing we have observed. Based on Spring.application name, your microservice will be registered, okay, to Eureka server. Okay. Next, each registered service will have some instance ID, and we can find it in this console. Okay. How we got this instance ID is based upon our configuration. Just observe, when our application is coming up, now it's the time to understand this configuration. We are simply pointing, okay, where is the server running? What is the service URL? So this is a default endpoint / Eureka. We need to pass it like this itself. Okay. The way you want to connect to database, this particular logical DB, we directly give it, right, DB, and then we provide, okay, this logical database we want to connect. So they have provided something like fixed name / Eureka. On this one they operate, and so nothing but you are providing the Eureka server destination. We said during production, Eureka also will run behind a load balancer. In that case, instead of using a localhost here, you will provide that load balancer related configuration, and then in the end / Eureka is going to come. So like this, step one, you identify where your Eureka server is running. Because of this, your registration is going to happen to this place because it's running here. So your service client will try to register to the server. That is the first configuration. Okay. Second, we are saying this microservice processing service true for these two parameters. We discussed these two parameters earlier. So we are saying yes, the current service should register themselves with Eureka, and we will use this also for fetching action. So lookup we will do, also registration we want to do. So generally every microservice you can enable these two things. So it will make both the areas accessible to you, registration as well as lookup. Okay, fine. Now, before we discuss this IP address, let's understand this last statement. So, okay, what is the instance ID it should use for registering to Eureka server? And what we have seen here is basically coming because of this configuration only. We have syntactically combined three things together. Spring application name. So just observe, the first part is Spring application name, colon, okay, IP address. So when we added the POM dependencies, okay, so in Spring Cloud related some jar, they have written a logic where they can identify the IP address of the machine where this server is running, and that is available in form of this property. So dynamically, whenever you add this kind of jar, some Spring Cloud dependency is also running in your application. There they have written some logic to check which IP address your machine is having, and we can simply use Spring Cloud.client.IP address, and that is the reason here it has mentioned the IP address as the second parameter. Why this IP address and all required, we will understand that. First, just learn the syntax here. So this is again a general practice. First, name of the service. Next, where it is running. Next, what port it is running on. So very commonly, people in production set it up in this manner, and it is running on port 8082. This IP and this service name. Three things together will give us a lot of clarity. Which service is running, where it is running, on what port it is running. So we combine it and make it as the instance ID. Okay, that's how it happens. Where is this value coming from? Spring.application name. Array, we have defined that here. Spring.application name is coming from here. Similarly, server.port is also coming from here only. So that's the last point. First field, last field are other properties which we have defined. Okay, and this thing is coming from Spring related configuration. They have read it and made it available to us. We can set it up. So that is what this is possible. Okay, fine. Now the next thing, let's understand this property. Okay, prefer IP address equal to true. Nothing but whenever you are trying to communicate, from one server to another, we are further giving an instruction. First, what? When this processing service is registering, we are giving an instruction to the service registry, okay, prefer to communicate using my IP address. Okay, what does that mean? So just imagine Stripe provider service is there. This guy will also register. It will register via its IP address details also. Okay. So even when this is registering, their IP is going to be tracked here. This guy is registering, IP is going to be tracked here. Next, when this lookup happens and you're trying to make a call, the call will happen based upon your IP address. So again, basically both things can happen, right? IP as well as domain. So for many projects, we just set it up, okay, use based upon IP. So it is going to uniquely identify the destination. IP is unique for every machine, and then communication will happen over the IP. So for that reason, we are putting it as IP. Okay, fine. So that is what it is. So IP address based communication. How can we see this IP address based communication? Just observe this, guys. If you go here, you click on this instance. Okay, you click on this instance. And what are we able to see? Yesterday, we have created an actuator health, right? For circuit breaker. Just observe. So whenever you are trying to call on this instance, I just clicked on it. It launched based upon the IP. That kind of communication is because we are asking it, okay, prefer my IP address for communications whenever that is happening. Okay, fine. So this is what we are. So what does this mean? This is my machine IP. So even let's say you go to Postman and you want to do a create payment activity. You can use even the machine IP for making the API call, right? I'm just trying to tell, okay, yes, the correct IP of the system is, okay, we need to be careful what we copy paste. Syntax should not break. And let's try to call it. Okay, super. So what has happened? My machine IP is taken, registered into Eureka. And whenever we clicked on this, it is internally able to map it to my IP and actually make the service call. And that is how these 4 configurations work. Okay, so fine. That is the next step. We need to register all our microservices as Eureka clients to the service registry. It includes, means both of these we have to do. Currently, we have done it for one of the service like payment processing, form configurations, annotations, some property file. We understood all the property file changes. Guys, are we clear with this so far? Team, are we clear with this? Guys, are you there? Are we clear, team? Please give a quick thumbs up. Are you listening? Okay. Same thing now we have to do for the Stripe provider. So concepts might be new, but steps are simple. Try to understand logical. The picture should be there in the mind. Okay, there is one service registry and we have multiple service. Their Eureka server is going to be activated. Every microservice should become a Eureka client. There are some configurations to make this thing possible. And you should logically understand, right? If there is a Eureka client, this guy wants to connect to the Eureka server. So details should be there, like where it is running and all. So we have provided. Next, this guy is going to register there. So how the registration will be? Okay, based upon IP address will be there, port will be there, a name of the service is there. So configurations are just like that. So always try to visualize it in mind so understanding becomes clear automatically. Okay, fine. So don't try to understand this only statement by statement. Diagrams help the brain to map the things logical, right? How will this guy know where to go? Okay, so we have to tell that via configuration. So registration, fine. So we have done this part. What is completed so far? Processing service is registered to service registry. You can go here, you can refresh it. Okay, just observe here. We just came with one of the service and that first half error message, first half is gone, right? Less than the threshold, something it was saying, because there were no instances. Now that message is just gone. It is talking about self-preservation because we have turned it off. We want that as soon as machine is not available, service registry remove it as well. Okay, what does that mean? It means if you are stopping this instance, okay, we want that it should be gone here. So yes, it is gone immediately without giving any grace period ki nahi, nahi, abhi network might be a problem. No, for testing purpose we want it to be as real time as possible. In production, don't do that because network sometimes might drop, and unnecessary you are cleaning up the service from the service registry. Okay, so do this kind of an experiment. Stop the processing service, and from service registry it should get deleted. Okay, okay, fine. Now let's bring it back again. So how do we bring it back? Right click, run as Spring Boot app. Okay, it is coming up, starting. Okay, it is registering itself with this particular name. So we can see that it should already come up. Yes, it is up this time. Now fine. So we have completed this. Processing service is registered. Okay, next aim will be Stripe provider service to also register as Eureka client. Okay, in service registry. How to do that? Same set of actions, no difference at all. Okay, first of all, let's go to pom.xml of Stripe provider service. You need to be very careful with your projects because same POM file is at multiple places, same property files are at multiple places. Don't accidentally make mistake here, some other property modifying there, something else. It will not work out, right? So be careful, be really focused when you do coding. Don't be distracted, because distraction will easily double or triple your time. If it takes 1 hour to do something, if you are distracted, it will take you 3 hours, because again and again you will lose the context, then you will go back to your phone, you will scroll on social media, then you will do a lot of chit chat, then come back, then again think what you were doing. So with distraction, definitely more time will be done, you will make silly mistakes. With focus, easily work can happen. So work with focus, it will simplify things a lot for you. Okay, so here we are, Stripe provider, pom.xml. Okay, we have not added any actuator here. So let's go ahead. First of all, Eureka and actuator, both of them we will be adding it. Okay, both of them we have added it. Now again, here the BOM configuration for Spring Cloud is not available, so we need to do that. Okay, please observe, for Spring AI also there is a bill of material configuration. So we already have this dependency management tag. Now we just need to add then one more tag here, nothing but this Spring Cloud dependencies we need to add. Earlier we added Spring AI related. Now we need to add Spring Cloud related. So you should not take the full tag again, right? Be careful. That's what I'm trying to show you the differences. Because in our Stripe provider, we already have added dependency management related tag. So in that, multiple dependencies are possible. We added earlier dependency for Spring AI dependency version for this guy. Now we need to add one more dependency here, which works for our cloud situation. And so take only that dependency tag, this one. I can put some enters here. So take only the dependency tag, not everything. It depends, right? In which project, what you're doing. So here, because we have Spring AI, so this tag is already available and we are just positioning this one. That's it. Okay, done. Let's save it. That compilation error is resolved. So you need to be careful depending upon the state of the project, which jars are there, which BOM configuration it needs. Accordingly, we have to apply the changes. Okay, fine, very good. So we have applied it. Eureka client, some actuator changes are applicable, and this one. Step number 1 completed. Step number 2, we need to make this enable discovery client. So you go to the project, you go to the main class. This is the same stuff here. Control Shift O, save it. Okay, here we are. And now we go further. Property file, we are not changing anything here. Okay. This should also register with the same service registry. So this will be same. This will be true, true, true. And this is also generic. So dynamically, this value will come based upon your Spring application we are running. So we will get Stripe provider service. So IP address will be dynamic, port will be dynamic. So basically, yes, everything, all the 4 things apply as it is. No need to change anything. So we will come here, we will go to local and Stripe provider, and let's put these changes. Perfect. Okay, let's save these things. Okay, just observe this. These are the logs of our processing service. Okay, and continuously behind the screen, some discovery client work is going on. So please be aware, between client and the service registry, a lot of communication is continuously keeping on happening. Okay, the response status is 200, getting all instances registered into Eureka server, and then trying to do a lot of things basically here. Okay, and continuously after every some time it will still keep doing these kind of things. Okay, so just be aware there is a communication happening between this client and the service registry. Okay, that's fine. Now we have done the changes inside Stripe provider. Everything is saved. Let's do a build once, because it is a new POM change also we have done. Package. Okay. You know that when we are building this, it starts test cases, right? Okay. Anyways, we were not able to catch it. I was just hoping, since it starts the test cases, okay, uh, maybe then it will register itself here. We can see that, and when it is down again. But yeah, we were not able to track it real time. Anyways, regardless of that, let's start the application now to check on the changes, okay, whether it does the work properly. So we go here, right click, run as Spring Boot app. Let's keep an eye on the logs. Okay, perfect. Registering application, Stripe provider service with Eureka, and the name is going to go like this. Instance ID is going to be like this. Perfect. Our current service Stripe provider is running on 8083, and via this IP we want to get it registered. Super. So looks like it's already available there. So we can go here and we can check it here. Perfect. So guys, Stripe provider service is also available. If you click on this link, again, based upon IP, communication is going to be attempted. Okay. We have not enabled the full actuator related information yet. So for that reason, it is not working out. We need to enable property file of actuator, which we have done it here. If you remember yesterday, we have enabled some actuator configuration property file, so we got it. So that is not enabled, so it did not come, but it still went to the server. So it tries to call some endpoints and get some behavior. But that's not the point. The point is when we click on this, it used the IP to communicate. That is what I am trying to tell you. Okay, fine. So we are done with the next step. We are done with the next step, which is Stripe provider to also register to this one. We added POM, we added enabled discovery client, and we added property. Okay, properties. And next we are able to verify it here that it is coming. We can take this as a screenshot, and instances currently registered with Eureka, we can just put it here. Okay, we can just put it here. Okay, now comes the third part, which is actually lookup to make this API call. How this service is going to communicate with this service. Very interesting. Okay, so guys, before we go there, let's take a quick 2 minutes break and then we will resume back. Okay, just a 2 minutes break, guys, and then we will be resuming back. Just a second, I'll get some water. 2 minutes break. Okay, chalo guys, coming back. Okay, guys, so team, are you there? Please give a quick thumbs up, then we will start. Okay, thank you for confirmation. Guys, ek kaam karte. Okay, in your notepad, you write down only bullet by bullet point, okay, how to do whatever we have done so far. I will ask you the right questions. Accordingly, start answering it in your notepad. Okay, because there are so many things. If you can think logically, you will be able to figure out. Okay, so in your notepad, just write down. Okay, what is the first step? Let's think about whatever we have done so far. Let's say if you want to technically implement it, what is your first step? Guys, let's think about it, everybody. Open up your notepad or wherever. If you are maybe watching on phone, open up any, let's say WhatsApp chat, there you can write, or if you have any text kind of tool or like whatever app installed, you can check it in that also. What is going to be your first step? Think about it. Logically, we have to progress. The way we do the coding, we do everything logically. First logical piece, second logical piece, that's how, right? So what is our first step? Okay, we need to set up a Eureka server, right? So write it down a bullet point. We need to set up a Eureka server. Next, write down the second. For setting up Eureka server, we need to create a separate Spring Boot project, right? Separate Spring Boot project. Next, add pom.xml plus annotation plus property file. Write it down, even at your side. This is the logical way, right? Add this. So, and after that, build and execute. Execute. Next, check the Eureka server console. Okay, this is our first related actions. Write it down, guys. Okay, what is the next thing? Both microservice should be registered as Eureka client. How you are going to do that? Again, POM plus annotation plus properties, and then we simply build and execute. Okay, check in console that both microservices are registered in Eureka. That logically only this much work. So hard. It might look like, okay, for example, let's say beginner level, you might be listening these terms for the first time and doing a different kind of setup for the first time. Try to take it in a logical manner itself, then it will make sense. If you're trying to mechanically understand, oh, step 1, step 2, step 3, step 5, step 6, no. You will get confused. You will be like, oh, what is going on? So you have to always approach in a systematic manner, put the right things. If you have 10 microservice, so you need to do it 10 times, right? For every microservice, then you register. So approach there very logically. Okay, fine. Chalo, two things done. Now comes the third thing. When one microservice wants to call another microservice, we said lookup action and then API call. Okay. So if you really observe, our use case is going to be when processing service is trying to call the Stripe provider. We will work upon this use case. You can do it in reverse also. When you are getting a notification in Stripe provider, right, webhook notification, then we are supposed to call processing. So that also will change to this one. How basically people do it is, okay, let's just observe. Within the project, all the microservice, if they are using this, they will always call it via service registry only. Within one project, if they decide to go ahead with approach number 2, all microservice communication they will implement via service registry itself. Or otherwise, they will go with approach number 1, where they will put some load balancers and accordingly communicate. So one style people will follow. So even though Stripe provider wants to call to processing for a webhook, they will also do lookup from service and then make the API call. So all internal communication will go using service registry. Please be aware of that. Don't think like, no, here I will do a load balancer based call, here I will do this one. Technically, it can be done, but why? Don't complicate the system. Follow one standard, so it is easy to code, easy to debug. Okay, that's how you try to keep it. Okay, fine. So now let's just imagine our use case. When processing service is trying to call Stripe provider service, we will be doing this kind of a lookup and then API call behavior. And if you really notice, we are making constant changes into our HTTP service engine. Earlier, we created one version of HTTP service engine, which is, yes, using our REST client and then making an API call, right? Then all that mechanism, success, failure handling, valid success, valid failure, give it back. Any no response case, throw an exception goes to the exception handler. That was our first version. Yesterday we came and then we changed the behavior using circuit breaker. When the exception is shown, then catch it, call the fallback, then continue further. So yesterday we tweaked some behavior. Now today, again, we are working on API call itself. Don't directly make it. Don't directly make the API call. Rather, we need to go via service registry. Again, a change. But very logical. So we don't have to make any big changes. We still need to use REST client itself. There are multiple ways to do that. We will stick with REST client itself. Just that we will use service registry for our resolution. Okay. How it happens, the concept is very interesting. Okay. Dekho. It's a step-by-step approach. How to do this thing technically? We have this service registry. Let's say we have this service registry and we have this processing service. All right. Okay. Next year. Okay. So let's say we have this processing service and you want to call this destination. Okay. Now, Spring team has given one configuration called as a load balancer configuration. Spring team has given a load balancer POM dependency. We can add that load balancer POM dependency here. Okay, means you don't need a AWS kind of load balancing activity. In order to work with this behavior, you can use this POM dependency which Spring has created called as a load balancer, add it here. Okay. Next, currently, when you are trying to call, guys, this is important. Please note, currently, when you are trying to call this guy to this guy, how do we have the code? Let's go to our code, local processing service. Currently, when you are trying to call, you are doing it like this. Current mechanism. Okay. Why this load balancer is in place, we will understand that. Hold on, one by one. Currently, when processing service is trying to call the destination service, we communicate it in this type. Now, if you are using service registry in between, your communication style is going to be different. It has a lot of changes to be done. Simple changes, but 2-3 changes needs to be done. But while you make the API call, you will be changing it to go like this. You will not use localhost colon 8083. Rather, okay, it has registered itself with some name. Okay, no need to go for this capital case, use it small itself. Internally, the library is going to decide. Nothing but notice, whatever your destination service instance is there, it is registered into Eureka with one logical application name. If multiple instances are running, auto scaling, then also the logical name is going to remain the same. So what you do is you go to this application.property of Stripe provider, and whatever is the application name, okay, you simply make this API call using this naming. That's it. Okay, what is going to happen? So if earlier we used to do like this, now we are saying we should do like this. This is one style of how communication can happen. Okay, what is this name? This name will be the name which is registered inside your Eureka. So what is going to happen? Let's imagine if there are 10 instances running. Okay, from 10, you need to pick only one. How do you do this kind of load balancing? You do that using this load balancer. Okay, using this load balancer. So what is going to happen? When you are trying to make this API call, in between, Eureka related work is going to happen automatically. You don't have to do any changes for that. We will use certain annotations. And when you are just calling this kind of an endpoint, it is going to go to Eureka and it is going to see for this name, how many instances are running. And those instances will come. And from that instance, the least loaded one is going to be finalized using this load balancer. And then accordingly, the call is going to happen. So multiple changes here we have to do. So first, instead of calling it like this, we need to use like this. And then we need to enable some load balancer configuration so that when you are calling this, you can actually go to service registry, pick the value, and then continue further. How to do that? Okay, let's look at the code. Then you will automatically get it. Then we will circle around the explanation one more time. So here we are. Third box. Making a call to another microservice. Again, as part of Spring Cloud project itself, load balancer is available. Okay, there is a technical term people use for this called as client-side load balancing. Nothing but you call the service registry, you get all the instances, and now you need to do some load balancing activity, and it is happening at the client side. So people term this thing as client-side load balancing. Okay, so again, yesterday we realized Spring Cloud is a project which these guys have created for like with tools or like some kind of features which will be used in a microservice based system. Now load balancer is one of this same feature. So Eureka Server, Eureka Client, load balancer, circuit breaker, these all projects are part of the Spring Cloud related, giving some mechanism to you. So this is client-side load balancing. So what is the approach? You will simply be putting this dependency. Next, you continue to call via REST client itself, so that you don't change. But you need to do one additional thing, guys. This one. Observe. We have to use one additional annotation called as @load balanced. And that annotation, okay, we need to apply it on builder, REST client dot builder. Just observe. This is important. Because of this @load balanced itself, the magic is going to happen. Because of this @load balanced, this builder is going to be created in a special manner. And this builder, if you notice how you are creating REST client, HTTP service engine. HTTP service engine currently gets a builder. Where is this builder coming? This is auto-configured. We have not defined any configuration for this builder. Spring has created a builder and it is giving here. We have used it, builder.build, got the REST client, and then we are making API call. So current implementation is like this. The REST client builder is auto-configured by Spring and is available inside container. We injected, we called the build method, it gave us a REST client, we called it. That is regular REST client builder. Now we need a load balanced REST client builder, nothing but a builder having the capability to do multiple things here. Okay, what is that capability? Load balanced, having multiple capability. Capability number one, it should be able to connect to Eureka Service Registry and get the destination. Okay, get the destination service instances based on application name. Second capability, it should be able to do client-side load balancing. Okay, so the regular builder that we have is not going to do this. The regular REST client builder that is available is not designed for this kind of work, to connect to some service registry and then pass this name and get the instance. It is not designed for all that work. So regular REST client builder is, give me an endpoint, I will call it. Okay, but now we want it to do it differently. We want that in the endpoint, we will give you the name of the application which is registered with service registry. And we will then make the API call the same way. We want internally REST client should first look up from service registry. So it should first look up from service registry and then pick the right destination and then call that right destination. So how REST client can do it? Okay, the approach is something like this. You have to then manually create the builder. Don't use the Spring provided auto-configured builder. We need to manually create the builder and annotate it with @load balanced. That's it. And yes, it will be a bean. So an object of this builder will be created. And we know that Spring Boot basics, when we are creating the object, Spring is not going to create its own builder object. So our object will be there in the container. That object will be injected here. You set it and then you use. So here code wise, you don't have to change anything. But additional behavior, the way we create this builder, that is happening in a different style. And that gives it capability, okay, connect to the Eureka server and then resolve to the right final instance also. Simple, one annotation doing the magic. देखो guys, how simple things are from implementation perspective. Concept is very interesting. Coding is what? One pom.xml, one annotation, this configuration, that's it. And yes, in the property file, then we have to use, okay, in the property file, we need to use something like this. That's it. So when you do this kind of thing, automatically everything happens. So please understand, learning how to code is very simple. POM, 1 line, 2 line, 3 line. But concept is so interesting. under the hood, if you use this kind of REST client builder, from this builder, you create a client object. And then when you're calling the method, because this builder is created separately, it will internally connect with the service registry, take the name, resolve which endpoint I should call, and then pick that and then call automatically. So much is internal implementation. Guys, that's the power of framework. It's like how to do all this, right? Lookup and making an API call. If you think like developers, you will be like, oh, we have to write some code where we first get it, and then we have to decide which endpoint to call, and then we can call it. Okay, no, it is much more simplified. Spring has done some more work for us just by this simple annotation. So first, let's test it, and after that, we will get into further drawing conclusions. Okay, so first, we want client-side load balancing in this case, because multiple instances are there. So we will go here. Even though let's say one instance is there, but we want to do it in this style. So because that's the general way. So we go here inside pom.xml of processing service and add this load balancer. Okay, save it. Go here, processing service. Project clean. Okay. Whenever we add a change here, we need to rebuild it or update the Maven pack project. So we will just follow a simple clean approach. Okay, this is done. Everything is saved. Right click, run as, Maven build, clean package. So step number one, load balancer, client side load balancing we have added. Okay. Now let's start the Spring Boot application. Let's start the Spring Boot application. Right click, run as. Okay, it's still going on. Huh? HTTP service engine. It's running test cases. It's doing some registration work. It is activating the container. It is ending it. It is calling the build. Jar is prepared. Everything is good. Right click, run as Spring Boot app. Okay, let's go. So we added load balancer. Now we are starting processing service. Okay, registration is done. You can go back here. You can refresh the page. Okay, both the instances are up and running. And we have added load balancer dependency here for client side load balancing. Everything should happen internally, right? So what are we going to do next? When we are trying to call, okay, when we are trying to call the destination, we will go ahead like this. Okay, let's try to take it. We will go back. Local processing service. This is our endpoint, right? We will take this, we will comment this, and we will assign it like this. Okay. So this name is coming based upon Spring application name of the Stripe provider service. And with this itself, it is registered with the Eureka. So we can use that. Okay, fine. So we provided this configuration. Now let's imagine in the current code, we have not added @load balancer. Let's just try to call it and see. Okay, yes, it has to get some. Let's see what happens basically. Okay, so we are going to check that flow. So current code itself. So first of all, one by one, let's do it. We will make a straight case via localhost. So no, not going through the concept of service registry at all. Let's look at a regular flow. Okay. Okay, let's look at a regular flow. We go here, initiate API, call. So it is working. So guys, they got technically, even after doing everything, if you bypass it, so it's like a developer's mistake, right? So you have built up service registry, you have registered everything there, but the developer is still very basic. Developer is thinking, I will still go via my traditional way. Don't do that. Like, everything is there and you are still doing it in whatever manner. No, you're not supposed to do it like this. Okay, so this is wrong. It works, but it is wrong. You are supposed to look it up from service registry and then accordingly continue, right? That's the model. So currently it worked. End to end it went, and we got the reply. Okay, now because it is directly trying to go there, so only for testing we did. Now we are commenting this and we are saying go via this route. Okay, so what is going to happen? Let's see. We will now try to call it. Okay, port is done, Tomcat started, fine. Let's try to call this. Okay, there is unable to connect to Stripe provider. Okay, and that was like, okay, expected. Some exceptions came. Unable to connect to Stripe provider. Unable to connect to Stripe provider. Just see, no such host is known. Means currently when we have provided Stripe provider service, the REST client is not able to understand, okay, what should I do? It is internally throwing caused by. We said whenever you see the exception trace, this caused by. So first line is going to be important. This everything in between is waste. First line is important. So IO error, when you are trying to call this IO error, and what is the reason? No such host is known. So first line itself is clear with what the problem is. But if you are not able to get it in the first line, you scroll down and try to read the, all this is waste. Just read this caused by. If that is not clear, read the next caused by. Fine. So here we can clearly understand no such host is known, and the same thing is available here. So we can confidently say when we are trying to call the endpoint like this, so REST client is not able to resolve which service to call, and it is leading into problems. That is the regular REST client behavior. Okay, now we need to change this. So in order to change this REST client behavior, okay, we need to use this @ load balanced and create our own bean here, this one. Nothing but REST client.builder. We are creating our own builder. And this builder which is returned back should be @ load balanced. This is important. Once we create this, let's go. Let's go in our configuration file, config, app config, model mapper we added earlier. Now we will be adding this one. Control A, Control I, Control Shift O. Okay, no need of making this public because only Spring calls it internally. We don't call this from outside. Fine, save. Okay, let the Spring Boot start automatically. Just see, negative match. Because we have provided, so Spring is not providing right now. So what would have happened? Because we created our @bean, so this object is created, and this object will be injected inside HTTP service engine here. Basics of Spring Boot, we discussed it earlier. And then using this builder, you are trying to do a REST client. Okay, let's test this code now. So everything is saved. Service application is up and running. And you go back to the Postman and then try to call it. It's working. Observe, we called based upon the same endpoint. It is working. Local, right? How interesting it is. You are not bothered about which machine that is running into which IP, which EC2 machine. You don't need to know that. You don't need to know which port it is running upon. You only need to know, okay, what is the Spring application name of the destination service? How intelligently this is happening, just observe. This name, we have read it into our HTTP service engine and is injected here. While we create the request, we have populated it here as part of URL. The simple REST client tries to call that URL. But while it is trying to call, this is not a regular REST client. This is a REST client which is created from a builder, which is load balanced builder, nothing but having the capability to connect to Eureka server and to resolve the endpoint for you. Internally, the builder logic is now very smarter. That is because of this app config. It is so interesting. If you don't write it like this, just commenting this load balanced, your capability to resolve all this is going to go. For example, if I just comment this load balanced, save it. If you comment the load balanced, let the Spring Boot come up. Unable to connect. What's the problem? Unable to connect. Unable to connect. Yeah, the same problem came back again. So just this annotation is giving that double behavior. Connect to service registry, pass the domain, get the destination IPs, load balance among them, and then call also. Dekho, for technical people, we don't have to do anything, right? POM, annotation, call. Same code of REST client. We did not even modify HTTP service engine. No change at all here. And it is working, but it's working differently. Under the hood, lookup and call is happening, right? So smart. Guys, are we clear with this? Are we clear with this? It is so interesting, guys, right? Are we clear with this? Team, give a quick thumbs up. So now today you have to apply the same configurations. I will give you the source code. You can go to ChatGPT, explore, it will give you the same commands. Okay, let's do that and then we will end the session. There are multiple other approaches of doing this. For example, I've even written one more approach here. There is something called as load balancer client. This is another style. Rather than using @load balanced annotation in your HTTP service engine, this will be auto wired. Okay, this is already a Spring Bean auto configured. You can directly inject this one, and then it provides a choose method. And in the choose method, you provide your service name. This is another style. You can practice this one also. Okay, you provide your service name. It is going to give you the right one instance, and you can use that instance, and then you can get the URL from there, and then you can call it further. So nothing but with this choose, you will get one of the instance from service registry, and then you can prepare the destination URL and then call it accordingly. So this kind of code can be additionally written, but again, it is more coding. You have to externally do it. So approach number one is more simple, and many times people will use like this when they are using REST client based approach. The builder, they configure it at load balanced, and then that they use while making call, and endpoint they simply use like this. Okay, so it really simplifies stuff. Now if you go to ChatGPT, it will start giving you the required answers. I want to set up Netflix Eureka server and client, and also make lookup and API call to another microservice using @load balanced. Give me step-by-step code. Java Spring Boot. Okay, you can skip it so we can get the results quickly. Okay, That's it. It took some example and how exactly to do that. Eureka server can be done like this. Enable Eureka server. Important parameters it provided. Just turning these two off. Dashboard, you can watch it here. Client, you need Eureka client. You just need to connect to the right server. Those two values are by default true. Okay, these two values are by default true. So if you don't write it, it is assumed that it will be considered. It did not use any instance ID naming and all. So we have overridden some of those factors for us. And then you enable the service discovery. And then, okay, you have some functionality. Service 2 also, you make it talk to the Eureka. You enable the discovery. Next, okay, just observe. So this is older style, right? REST template. Okay, if we are using something like Spring Boot more than 3.2 version, so then we will have this, and it is automatically saying, okay, when you are creating the REST client builder, then use this load balanced. Okay, and then accordingly we can further work with it. So it gave an example of REST template, and that is what is the thing. If you specify, okay, we are using this one, okay, Spring Boot 3, and give me only this one, it will provide accordingly. But it has read so much of internet information that previously REST template was always used, so it has given that way also. So if you are using REST template, you can load balance that as well, or otherwise, yes, take the builder, balance it out, and then while making service call, you just need the client, and then you call your destination method. So everything came properly. Everything came properly. Okay, and make API call from this. This is fine. It did not explain how the configuration is there. Okay, it didn't. When the service 1 is trying to call service 2, where is the configuration? It did not mention that. Okay, or did he hard code it? Yeah, here it hard coded. Just observe. Hello, instead of writing it in a property file, hard coded. Here it is saying directly use service A, the name of the service A, and after that whatever endpoint it is. So correct. So it is putting it in the expected manner, just that it has to come from some property file. But yes, you can call. So if you can think, AI is having all the solutions. You just need to have the patience to find it, apply it, and just observe. Step by step, everything came. That is where application development is getting more and more easier. But you need to know these concepts that, okay, what is service registry, how to register, how to do the lookup. So don't think that programming knowledge is not required. How will you understand all these concepts? That you have to learn anyways. Now, coding is simplified, but conceptual knowledge, maturity is still required. So that is where we have to still learn all these things and then do it all practically, and then use AI to code in a faster manner. So you don't have to rely on this kind of a document. Rather, your AI is going to give you all the required code, and then problems will come, read that, errors will come, solve that, and then you become more evolved. And guys, actually, in one of a meeting recently, I was into one of a meeting with the director of a company, and what that guy told is, because now YB coding is there, Cursor and GitHub and Chat GPT, it is giving so much of code. That guy just said ki we have one possible thought ki because it is becoming easy, so then maybe that much great salaries might not be there for regular developers. Why? Because earlier it was more hard, now it is more easy. So market can correct the salary structure of the developers. Okay. So what earlier people were getting very huge packages, even for regular application development, you can expect some change to happen in that. That is what they said. Another thing they said, ki maybe the way generally when there is a developer and there is a tester, packages of testers will be less compared to packages of developers on an average. Okay, some greater wale randomly you can find, but they are now saying ki, okay, now the market will shift. The value of developer will be considered less than those of maybe AI developer or specialists or experts in the next level stuff. Maybe data science, data engineering, AI, cloud related. So along with your regular development knowledge, you become expert into the subject matter also, because there we can expect still good packages, market is still tight there. So you have to gain this knowledge and then try to go here. So you will be still more relevant, right? So, but please understand, AI has to be used, it has to be adopted. Plus at the same time, this is basic. Learn this, understand this, and try to go to the next level. Maybe in the next 6 months to 1 year, you should become a master in the next level also, because the world is moving in that direction, right? So please take care of those areas. Okay, guys. So that's it for today's session. Guys, everything clear? Everything clear? Please give a quick thumbs up. So today we need to practically do all these things. And I can understand you guys are just getting started, and in front of you, the IT world is changing. So it's a very different time for you to get started. Like when we started, whatever IT was running, some changes were there, but it was not like, oh, the world is changing. For you, the world is changing in front of your eyes. So you have to first learn the regular application development way, because without that you cannot build the next level softwares. So first gain this mastery, plus work now more hard to go to the next level also, right? Both things are required, and the market will expect that. Okay. So thank you everybody for your time. Have a great day. See you guys tomorrow morning again 10 a.m. We will be connecting for logging topic, and it is going to be the last topic of this August related thing, right? And if you are still making demos, complete your demos also. And this weekend we will issue another set of completion letters for recent members. Okay. So guys, there is no attendance. Have a great day, and see you guys tomorrow morning 10 a.m. Okay. Thank you guys. Take care. Keep growing. Okay. Maza aega. So when the world is changing, it is more interesting for you. Okay. Why? Because you are going to learn things the way experienced people are learning. You are also learning the same. So competition wise, if you work really hard, you can compete with them.